Howdy, howdy, PreCalc. It's Monday. You'll be watching this after Monday's class. I should have it up by 5. I hope that's not too late for everyone. I've had the stomach bug. It's been awful, but I'll leave that up to your imagination without any more details. Let's go ahead and see what is in store for us. I hope you all are well. We'll be watching this after Monday's class, but we'll be at Philly tomorrow. So that means you have to watch this by Wednesday morning. All right, so let us go ahead and proceed. We're in review mode, and hopefully you were able to do some of the Conic review today in class, but if you didn't get to it, or didn't remember well, I'm going to bring that all back to mind. So, reviewing conic sections. What you'll be doing on the test is you'll be given an expression such as this one. Please write this down. It would be nice to have all our conic work on 1 or 2 pages. All right, so I'll be asking you to identify what it is and then graph it. So if you don't know what it is, it's going to be tricky for you. So in this one, you'll see there's only one squared term. There's no y squared. So that is a parabola. There's only one squared term. It could also be a y squared term, but then there would have been no x squared term. So right away, you'll have to recall the standard form for a parabola. It could be this, or it could be this. All right, either one. So in this one, you can tell which one we're working with, because we have an x squared term, is going to be this one. But it'll work very similarly if you have this one. We also remembered when the x squared term is in the problem, it's a vertical. And when there's a y squared term in it, it is a horizontal. So here we have a vertical. All right, so that means the opening is going to be up or downward. Let's go ahead and put it in standard form then. So we're looking for this kind of a form. So I'm going to gather my x terms. And I'm going to move my y terms to the other side and my constants to the other side. All right. Now that I did that, I am going to, it's always easier to work with the first term being positive. So I think I'll multiply through, if you will say that's okay, and change the signs of everything. So this negative x squared becomes a positive. So it's like I'm taking this first expression, multiplying through by a -1. Just for a little, it will work either way, just a little less complications. You can always do that. Now I will complete the square. And to complete the square, I take half of this and square it. So my special number is 25, which I must add to the other side. And now, let's keep this out of the way. I have the perfect square. All right, this one didn't turn out to be a great example because I don't have to factor this side, but normally if this y has a value in front of it, you want to pull it out and factor it like this, so it looks like this. All right, so I will factor it out in that sort of a trivial factoring. I pull out a 1 just to show you that what the 4p is. Whatever's in this position, whatever you factored out of both of these terms, will be equal to 4p. So 4p equals 1 in this case, and p is 1/4. And the vertex is 5 minus 4. Always the opposite of this and the opposite of that. Hector and Kyle. All right, let's begin our sketch. We are in standard form, so let's sketch a Rooney. All right. The sketch will first find the vertex. 5 over and 4 down leads us right there. And from that, and we know it's either going to open up or open downward. So let's look at P, and it will tell us which way. A positive P will mean that it opens upward. So a negative P means it opens downward. If we were going to have a parabola where the y term was squared, then we would have one that opened left and right. In that scenario, a positive P opens to the right and a negative P opens to the left. All right, but in this particular example, we have a positive P and it's 1/4. So that means 1/4 away is the focus. So that means this parabola is going to envelop the focus and open upward. Now I just need to know how fat. So that's not the parabola. So I'm going to do a sissy chart. Put an X, and I'm going to go back to the original and put an X is 0, and then I get Y equals 21. All right, when X is 0, Y is 21. So 0 up 21, okay. All the way up there. All right, way up there. So we have a parabola that comes down from the moon, grabs the vertex, and goes back up. All right, so that's that one. All right. Let's go on and do one of each. So that was our parabola. See what you think about this one. Negative 25x squared plus y squared minus 100x minus 125 equals 0. All right, so here I have an x squared term and a y squared term, and I recognize this as because they have the x squared term and the y squared term do not have the same coefficient. This is an unwritten 1, this is a negative 25, and they have opposite signs, then we know we have a hyperbola. Alright, so the hyperbola, right away we look at standard form. Alright, so that's standard form, and sometimes it goes the other way, where the y squared, oops, hyperbola, this is negative, sorry, important change there. Make sure you heard me, this is negative, and then the other way is when the y squared term is the positive 1, and the x squared term is behind the negative sign. Right, so it's either going to be this or this, so we will see what washes out. It looks like the x squared term, can you see that negative sign there? Looks a little faint. It looks like our y squared term looks like this one, so we're going to aim for this. And that means we'll have, when the x squared term is positive, we have horizontal. When the y squared term is the positive one, we have a vertical. So that's what we're expecting. All right. Let's gather our x and gather our y. I'll put the y squared first because it's positive, and then there's no other y term, so that means Kyle is 0. So then I have the x squared terms behind the negative sign. So when I grab this one, I have to take the opposite sign because that negative sign in front will adjust it, and take the 125 to the other side. Now we have to, before we complete the square, we have to factor so that the lead coefficient is 1. So I'm going to pull out a 25. Complete the square. Half of 4 is 2. Squared is 4, but it's really a minus 100. So I have to adjust for that. What is the perfect square that I've created? X plus 2 equals 25. Almost to standard form, but I need a 1. So I'll divide everything by 25. Which works out nice and sweet. Y squared over 25 minus x plus 2 squared over 1 equals 1. Alright, standard form, we're ready to graph. Alright, so this turned out to be a vertical, as we mentioned. So the openings are going to be upward and downward. The center is going to be a -2 and a 0. So I'm going to graph that. And if you recall, we're doing hyperbola, we do an XY box. And now that we found the center, we'll drop Hector and Kyle. So it'll look like this. Y squared over 25 minus x squared over 1 equals 1. So using that augmented form, we're going to put a 0 for x and solve for y, and we get plus or minus 5. And when we zero out we zero out y, we get a plus or minus 1i. Alright, this tells us this point will be on the actual hyperbola. This one will not, but it'll help us get the box. So from the center, we're going to go up 5 and down 5. Over 1, over 1. Make our box. The diagonals. And this is the real part. This is is not on the hyperbola. Plus we also know it's a vertical. So there's our hyperb. Alright. I'm going to shut this down and start part 2 for the next ones.